Hello class, today we're going to be talking about properties of quadratics. So quadratics have quite a bit of properties. We want to identify where these different properties are on the quadratic and more importantly on the graph. So here I have graphed two quadratics for you. One is opening up, one is opening down. There's just a slight difference between the two, but we'll kind of go through the properties that we're going to be talking about. First, the x-intercepts. Those are what I've written in blue. That's where the function crosses the x-axis. Next would be the y-intercept. That is what I have in light purple here. That is where the function crosses the y-axis. This will only have one of them. And then next will be the vertex. That's what I have in green here. Notice that the vertex is either the lowest point or the highest point of the function, and then the axis of symmetry, which is the line where the functions are symmetrical about each other. So the left half is exactly the exact same as the right half symmetrically. Okay, and then finally min or max. That's just is the vertex a min or is the vertex a max? And we can determine that whether it opens up or opens down. Looking at the function, we can determine that if it's positive or negative. So, to get these five things, this is what we need in order to find them. The x-intercepts, we use the quadratic formula to find them. The y-intercept, that one's easy. We just identify the constant. So it's the number in the function that does not have an x on it. Then the vertex, remember, we use the vertex formula to find the x value and plug in that x value to get the y value. And then the axis of symmetry is just the x value of the vertex, so that one's easy once you have the vertex. And then min or max, just determine positivity. Is the x squared term positive or negative? So is there a minus right in front of the x squared term? Right? If it's minus, you'll have a max. If it's positive, you'll have a min. And why? Well, if it's a positive, it'll open up, meaning we'll have a min. If it's negative, it'll open down, which means it will have a max. So just something you have to remember. Well, there's nothing like the good old-fashioned trying it out yourself, right? So let's get to it. So we're going to start off with the x-intercept, and we're going to use the quadratic formula on this first example. X squared equals negative 8x plus 12. And just so we have it, I'll write it for us. X equals negative b plus or minus square root of b squared minus 4ac, all divided by 2a. So first, when finding the y-intercept, we want to define our a, b, and c, if you recall. So our a is the coefficient of the x squared term, so that's 1. B is the coefficient of the x term, that's negative 8. Be careful with that negative there. There is a negative. And then c is the constant term. That's 12. So let's just plug this into the quadratic formula and simplify and see what we get. So x equals negative b, so negative 8, plus or minus the square root of b squared, so negative 8 squared, minus 4 times a, which is 1, and times c, which is 12. All divided by 2 over a, so 2 times 1. Now we're going to simplify this. Remember just how we read a book, top left to right, and then the bottom left to right. So let's see here. X equals negative 8 is positive 8, plus or minus the square root of negative 8 squared is going to give us 64. And remember, I like to do this whole next part all at once. So 4 times 1, or negative 4 times 1 is negative 4, times 12 is negative 48. So we're going to have a minus 48, all over 2 times 1, which is just 2. At this point, we'll continue simplifying under the radical, under the square root sign. So we have x equals 8 plus or minus 64 minus 48, it's going to be 16 over 2 And at this point, we can take the square root of 16. Let's see. I want to do this okay. We'll come back up here. Square root of 16 is 4, so x equals 8 plus or minus 4 divided by 2. And then we can split it into two different equations here. One, we're going to have x equals 8 plus 4 divided by 2. And the other one, we're going to have 8 minus 4 divided by 2. So to simplify each, 8 plus 4 is 12, divided by 2 is 6. 8 minus 4 is 4, divided by 2 is 2. So we have our x-intercepts. So our x-intercepts is going to be x equals 2, 6. Now to find the y-intercept. This one's really easy. This one, just identify the constant. In fact, I'll do a different color here. I never use this one. We'll use pink. That's a nice one. Okay. I don't know why I use that one more often. Okay, so the y-intercept is just 12. It's just whatever this number is. That's really easy. It's nice. The vertex, we're going to use the vertex formula. So recall that the vertex formula is x equals negative b over 2a, which, if you are, or if you have been especially observant, you'll have noticed it is the very first part of the quadratic formula, negative b over 2a. So our a's and b's are the same as up here, so we can just borrow from here, or just use the same ones. X, let's see, so b is negative 8, so it's going to be x equals negative 8 over 2 times a, which is 1. So negative 8 is positive 8, divided by 2 times 1 is 2, 8 divided by 2 is 4. So our vertex, it's going to be a coordinates, right? What is the x value? What is the y value? Well, the x value is 4. We know that because we just plugged it into the quadratic, or the vertex formula. There we go. Now to find the y value, we want to plug 4 back into the equation, just like what we're doing when we're working with minimizations and maximizations of these quadratics. Which makes sense, because we want to find the vertex is the min or the max of the function, isn't it? So let's evaluate the function at 4. So f of 4 equals x squared, so 4 squared, minus 8x, so minus 8 times 4, plus 12. And we will have 4 squared is 16. Negative 8 times negative 8 times 4 is negative 32. Plus 12. Well, 16 minus 32 is negative 16. Plus 12 is negative 4. So our vertex in this case is at 4, negative 4. And then it asks for the axis of symmetry. That's just going to be an x value. And it's the x value that's the same as the x value of the vertex, because that's where the symmetry happens. So x is equal to 4. And then min or max, well, does this open up or does it open down? This does not have a negative in front, which means it's going to open like this, which means that it has a min. So this has a min, just like that. All right, let's do another example here. And they don't get any harder. It's just very time consuming. The algebra can be challenging. It's a lot of algebra. So let's find the x-intercepts first. So to do that, we're going to use the quadratic formula. So let's first define our a, b, and c. A is going to be -1 in this case. B is -2. And C is 15. By the way, are there things that we can answer immediately just by seeing this? There are. There are, in fact, 2 of them. We can answer the y-intercept and the min and max just by looking at the function. Well, the y-intercept is just the last value. So that's going to be 15. It's just our c, so y equals 15. Min or max, we can determine whether it opens up or down. This opens down, so the vertex is going to be a max. It's going to be a maximum high point. So just 2 things we could answer right off the bat. Kind of makes it seem a lot less intimidating. But let's go through find these x-intercepts. So we're going to plug it into the quadratic formula. So x equals -b, so -2, plus or minus the square root of -2 squared minus 4 times a, which is -1, times c, which is 15, all divided by 2a, so 2 times -1. And then simplify. -2 is +2, plus or minus square root of -2 squared is 4. -4 times -1 is +4. +4 times 15 is 60, so it's going to be plus 60. All divided by 2 times -1, that's -2. And then simplify under the square root still. So x equals 2 plus or minus the square root of 64 divided by 2. We know the square root of 64, so we can continue. Square root of 64 is 8. So x equals 2 plus or minus 8 over 2. Oh, over negative. I dropped that negative. Oops. And then now we can split our equation into 2. X equals 2 plus 8 over -2, and x equals 2 minus 8 over -2. So 2 plus 8 is 10, divided by -2 is going to be -5. Remember, the positive time divided by a negative is a negative. And then -2 minus 8 is going to be -10. -10 divided by -2 is positive 5. Oh, I'm sorry, this should be a positive right here. I was wondering why they both came out as 5 and -5. So remember, so this should be a positive. I just accidentally drew this as a negative. So 2 minus 8 is -6 divided by -2 is positive 3. And that's that. Those are our x-intercepts. So x equals -5 and 3. All right, we've got the hard one out of the way. So now we just have left the vertex and axis of symmetry. So the vertex, we're going to use the vertex formula, which, if we recall, x equals -b over 2a, the same thing as the beginning of the quadratic formula. And b we defined as -2, so it's going to be -2 divided by 2 times a, which is 2 times -1, which is going to be positive on top, and 2 times -1 is -2 on bottom. Well, 2 divided by -2 is just -1. So the x value of our vertex is -1. Now to find the y value, we take this function, or take what we get and plug it right back in, right? So f of -1 is equal to -1 squared minus 2 times -1 plus 15. And let's go through this. So -1 squared is +1, so it's going to be negative times a +1 now. if that makes sense. We still have this negative out front, so that we haven't done anything with that yet. And then negative 2 times negative 1 is positive 2, and then plus 15. I'm going to go this way. I'm running out of room. So this is a negative 1, really. So negative 1 plus 2 plus 15. Negative 1 plus 2 is 1, plus 15 is 16. So this vertex is at negative 1, 16. That was our y value of the vertex. And then finally, our axis of symmetry is the x value of the vertex. Once you have that, it's easy to find. X equals negative 1. And there you have it. So basically what we're doing is we're just using the quadratic formula, and we're using the vertex formula, and then plugging that value back in. Everything else is just you can look at it, kind of see it, okay? So that's all I have for y'all. Let me know if you have any questions. Have a good day. Bye.